Hello all, welcome back to Troubleshooting Python application development, where we're helping you make faster applications and applications that reduce its memory footprint. So today we're going to start a new section about organizing our code with better object-oriented programming techniques. So the reason we're doing this is in the last 5 sections we talked about measuring your applications and various techniques that we can use to explicitly change our code in a way that increases our application performance. One of the other aspects of application development is how fast can you deliver features and how readable and maintainable your code is. I've put in this section about object-oriented programming to help you create code that is maintainable and technical debts free, well, I say free, minimized, so that not only are your apps running fast, it also is developed quickly for its users. We're going to bring this topic to you in 5 steps. We're going to first talk about how we can stop modifying the wrong object instance with correct object cloning. We then talk about speeding up our OOP with named tuples, reducing getters and setters with static methods and properties, comparing 2 different objects, and then lastly, improving readability with abstract-based classes in Python. In our first video, we're going to talk about stop modifying the wrong object instance with the correct object cloning. In this video, we're going to take a look at how we can copy and clone objects in the right way. Let's dive right in. So to show you how we can do object-oriented programming in a very simple and straightforward manner, I'm using Jupyter Notebook here. It's a very powerful tool for you to quickly iterate through different versions of your code and test out different things. So the problem here we have is sometimes if you are simply taking one object and then assigning it a different name, a different variable name, and you change the content of that new variable, you often inadvertently change the value of both variables. And that's because Python is smart in a way and not that smart in another way. So it's smart in a way that when you do something like in7, where you are taking the original list, a nested list, and assigning it to a copy, it tries to smartly save you space by saying, hey, these 2 objects are the same. We're just assigning a new name to it. Let's create a new reference to this list primitive here and call it a day, because we don't really need to create any new fundamental memory space for a copy of the original, right? Because Python thinks it's very unlikely that you actually will need an actual copy. So if we see here, we have an original list in in1, and we are assigning a new name. We're assigning this value original to copy, which is the copy of this object. If we append 5, 6 as a list to the copy, then you would see that, actually I've appended it twice here, I've ran this code twice, but we have appended 5, 6 to the copy, which is fine. But if we inspect original, we see that we also have appended 5, 6 to original. So that's not ideal, right? Because the original object is not supposed to be touched. You're only supposed to append a 2-item list to the copy of the nested list. So how do we deal with this? The first strategy is we can do what's called a shallow copy. And the way we do a shallow copy is by calling the instance creator for the data type that we're looking at. So for example, here we have a list. So we call the list and then we give the original to the list. So now if we compare original and shadow copy, we see that we have original on one side and shadow copy on the other side. If we append a 1-item list to shadow copy and we compare them again, we can see that original now is untouched in out12 and shadow copy is touched. So that gives us what we wanted, where we copied something, changed the copy, and we didn't affect the original. But wait, what if we try to touch the sub-elements inside the list, i.e. the second nested list in shallow copy? So let's say we assign shallow copy first item and the first item in the first item to be XYZ, a string. We look at shadow copy and we see that we have successfully changed the first item into XYZ, but then if we look at original, it has also been changed. And the reason that this happens is because shadow copy actually creates a copy only for the first level of indirection or reference. So here, if we're changing the first level like we're doing here with the append, we'll not change the original, but if we change the second level, we'll then change the original, which is why it's called a shallow copy. So to combat this, we need to use deep copy. So deep copy, to use this, we need to import the module copy. It's a built-in module in the Python language. We then create a deep copied list and call copy.deepCopy the original. We show the deep copied list in out 17 and the original in out 18. If we append a new list to the deep copied list, we can see that the deep copied list has a new item at the end, but the original is untouched. If we again try to assign one of the second level items a value, so if we assign ABC to the first item of the first item in deep copied list, we can see that the deep copied list has changed, but the original remains intact. And that's how we can clone objects around and copy objects around without having the original being tangled with the copy that you're going to subject to further processing with. And that's all there is to it. So we've just learned about how we can copy and clone objects in the right way. It's very useful when you are doing OOP as a paradigm in your code and you want to create a copy of the object to do something with it and then maybe return it together with the original version. To do this effectively, using copy and deep copy would really help you make sure that you're not modifying values that you're not supposed to modify.